By opening up www.www, we can have a look inside and see what kind of information is in there and how does that help us in establishing the behaviour of this particular piece of malware. We can see that a timestamp is inserted into this file, so we can only at this stage surmise that perhaps this is used for either a mechanism to control when to connect to the botnet command and control center, or perhaps when to initiate an automatic update of this particular piece of malware. At this stage we're not quite sure. Opening up Wireshark, we can see some interesting activity. The particular piece of malware appears to be causing our machine to query looking for a particular host. We're using NetBIOS name services at this stage, assuming that perhaps a DNS entry has not been found because we're contained within our virtual environment. You can see here that a particular packet is destined for port 137, so a NetBIOS name service call has been made, and the query in particular looking for ly1.no-ip.biz. In order to interact with this piece of malware, we can actually add an entry to our local host file. So I'll just browse through the file system at the moment, through the C drive, into Windows, into System32. Just to speed that up, just use the keyboard shortcuts. So we'll just click on an icon and press S to jump straight down to all the directories that begin with the letter S. Opening up System32, looking for our drivers folder, etc, hosts, and we can edit this file with Notepad and add an entry for a virtual machine on our network, in order for the piece of malware to try and connect to it, and then we can note what changes in the behaviour of the malware to try and follow its path and find out exactly what it's trying to do. So I'm going to add an entry in for 192.168.10.131, and then add in the particular host name that the piece of malware is trying to resolve. So ly1.no-ip.biz. We'll save that now, file save. That'll save our host file, and we'll watch closely at our Wireshark to try and note if any changes take place. So all the time we're trying to add as much information to our system to cause the malware to react and behave differently, and then note any changes. So straight away we're starting to notice that something's going on. We can see a number of TCP connections attempting to connect to destination port 81. This particular piece of malware is trying to connect to a remote server on port 81, so we're going to try and simulate that. I've moved on to my Linux machine. I've got Netcat listening on port 81, awaiting any incoming connections. So far we're not seeing any particular useful information, so we're going to just flick back to Wireshark and try and establish some more information about this particular piece of malware so that we can interact with it further. Switching back to Wireshark, you can see that we've got a number of TCP packets attempting to connect on 81, so we're just going to follow this TCP stream to see if we can find any useful information. Not a lot going on in this particular stream content that we can use at this stage. It's quite useful in Wireshark how we can follow particular streams and look at the data payload and try and establish what's its purpose, what's it trying to do, and gather as much information as we can about the malware and build that into our understanding of this malware so that we can try and interact with it as much as possible to see what it does and catalogue its intent. Browsing through Wireshark, I'm looking for other information that might be useful to try and establish exactly what's going on. I'm going to have a look to see if there's any other DNS related queries being created, so I've added a filter for DNS. We can see with the DNS protocol packets are being sent and the queries are being sent, looking for reverse lookups. Also here we can see that DNS entries are now being added to our Wireshark stream for queries for ftp.ly1.co.uk. So again, we can simulate this particular service on our system. We're going to add another host file entry for that particular FTP server. So again, pointing it to 192.168.10.131, an entry for ftp.ly1.co.uk. We can save that. We're now going to switch to our Linux box, and what I want to do now is install virtual VFTP server. So I'm going to use sudo apt-get space install space vsftpd, provide my password. I'm just going to install these packages without verification, so just say yes. We now have an FTP service started and running. We can check that that's running by typing in service, sudo service vsftpd start. So we know now that we have got our FTP server running. We can confirm that using netstat -ant. The NT will show the active ports that have been listening, and also numerical instead of trying to resolve them to a particular service name. Switching back to Wireshark, we can now see that the machine is trying to connect an FTP. So it's trying to FTP and it's passing a particular username. We can follow this TCP stream. We can see here the user, PHIBER at BADENPR.com, and the particular password, GSX123. So we're getting some more information now out of this piece of malware, and we can add this to our Linux setup. We can go over there and add a user. So we now use user add. Again, add my sudo, paste in the particular username, add the -m to create the working directories, use passwd to set the user's password, forget my sudo of course, just add that in now. So I'm going to put in the exact same password that the malware is expecting to use, that we gathered from Wireshark already. And now we're going to monitor and see what's happening. We can note here that we can see there's a request to log in successful, but we can see there's also a request to change working directory into a particular directory, /logs. We can see here we're getting a 550 error message telling us it's failed to change directory because the directory does not exist. So we're going to have to make a directory called logs. You can see now that the directory is there. We have to change ownership of the directory to the user, so the user is able to write. We'll use nano to edit our FTP server's config file, so we can make sure that the directory is writable. So we'll just uncomment this particular line. So write _enable equals yes, activated the directory. We should now be able to write to that directory using FTP. Now we can see that the server's response is good. We can see that the user is logging in successfully. We can also change the time display, so we can have a look at the time display in a format that you'll be able to quickly understand. With login successful, we can see that there's an attempt to send some data. So we're attempting to copy some data from our machine that's infected with the malware to our FTP server, and that transfer has been completed. So we can go and have a look at that now. You can go into the directory, we can see the file has been created by the piece of malware. We're going to use cat. We're going to cat that particular file, and we can see the contents of the file. So the contents of the file again appears to be encoded or encrypted in some way. Again, something we would need to look at reverse engineering in order to understand what techniques being used in order to decode and read this information further. Hopefully from this video you've got a good idea of the tools involved with malware analysis, and that's it for now.